Hello and welcome. In this video, I'll be solving question 9. So question 9, we have to read the question carefully. The diagram below represents a printed poster. Rectangle ABCD is the part on which the text is printed, right? So this shaded area ABCD, saving an area of that, and AD it's X. ABCD is X from the left and the right of the edges of the page, and 3 centimeters from the top and bottom of the page, right? I think it's very easy if you're looking at the diagram there, because you can see each of those lengths there. They're well presented there. We can see that, and we can see the rectangular part which on which the text is printed, right? So the first question wants us to prove or to show that the total area of the page is given by that, right? So how can we show the total area of the page? That it's given by that. So to get the area of this page, we can see that here we have the lengths. It's 3 and 3, right? And then, so this is the dimensions of this page. You can say this is length times the breadth, right? So the area of the whole page is going to be length times breadth, right? So do we know the length? We know that the length it's going to be 3. Know that the length it's going to be 4 centimeters plus 4 centimeters, right? This 4 centimeter plus this 4 centimeter here. So it's going to be 4 plus 4 plus BC, which is this BC from B to C. We don't know the length of that, but then they said the length of BC it's X, the length of AD it's given to be X. So if that's X, then it means that BC is X, right? So here we'll just use X times, what is the breadth? The breadth of that, it's 3 plus 3 plus AB, right? So now we don't have any expression for AB, but we can make use of some information that we have there to calculate for the AB, right? So we will not be able to solve this if we don't have AB, right? So this is going to be 8 plus X, and now here we have 6 plus AB. So now let's go and get what is AB, because in our area formula we don't have AB. It's only in terms of X, right? So let's go and get AB. We can make use of the area of ABC. So the area of ABC it's given, ABCD it's given there. So it's going to be X, which is BC, or AD. So the length of that, it's the area, it's AD times AB, right? So it means that AD here, it's going to be X times the AB length. It's just AB. Then we have the area's value here. It's 432. So now we'd have AB X with 432. So we'll divide both sides by X, because we want to make AB the subject of the formula so that we can substitute it there. Dividing by X both sides, we'll be left with the AB expression being 432 over X. So now we will go to the area of the page. So this is the area of the page, right? So area of page is equal to 8 plus x, and then 6 plus 432 over x. Now let's do the multiplication here and see if we will get to that. Right, so 8 times 6 would give us, so we'll get 48, and then that times that, 432 times 8, we will get plus 3, 4, 5, 6 over x, right? Because remember here, when we multiply with a fraction, this is just over 1. So we multiply the numbers at the top and multiply 1 times x, so get x, right? So let's multiply the 2, this 2, it will give us plus 6x. And the last ones, it will give us plus 432. Because this is over 1, x is going to cross cancel with the x. Because here would get x over x, and then they would cancel, right? So the x's go away. So now we'll have something like that. So now here we can add like terms, we can rearrange 3, 4, 5, 6 over x with the plus 6x there. And then these two, when we add them, are like terms, we would get 480. And we've managed to show that the area of the page, it's indeed that, right? So let's go to 9.2 here. Determine the value of x such that the total area of the page will be at minimum. So even if we couldn't prove that, the fact that we're given the area of the page, we can make use of that and get its first derivative and get the first derivative from that. So let's get the first derivative of this. So we have to first change this, simplify this, and change it into its simplest exponential form according to the rules of differentiation. So multiply this with that, minus 3, 4, 5, 6, x minus 2 plus 6, and then equate it to 0. We would get minus 3, 4, 5, 6 all over x squared plus 6. So we can take this, transpose it to the right hand side. We would get 3, 4, 5, 6 all over x squared, which is equal to 6. Then we can cross multiply this. So we'd get that the answer is 6x squared, 3, 4, 5, 6. Divide both sides by 6. And then we'd get x squared. We'd get x squared is equal to 576. Then we introduce the square root both sides. And then the x value such that the total of the area of the page, such that the area of the page is at minimum, would be the square root of the answer. And it's 24. So that's perfectly fine there. It's possible, you just have to think about what you're given, and you have to be comfortable with working with expressions, simplification, and substitution. So if you look at it, it has that vibe of simultaneous equations, sort of, because we have an unknown, we have something which is unwanted, or it's unknown, or it's an unknown, and then we have too many unknowns there, and then we use some information we have to create an equation to substitute what we do not want, right? And just to have only one variable in the equation, or just to be able to deal with one variable, right? I think it's perfectly fine there with this one. And your minimum x was that 24, and bye.